Hi guys, in this video we're going to review how to solve for y. I'm going to just run through an example and walk through some of the really important parts of solving equations, especially solving for variables like this. So first we're going to look at the example of 3x plus 4y equals 8. Now the goal of this problem is eventually to get it in the form of y equals something over here. And the something over here is going to have x's in it. We are just trying to figure out what needs to go in this side of the equation. So we are going to try to isolate the y. So we're going to do this by first subtracting 3x from both sides. This is an important part of solving equations, is that you have to maintain a balance. So if I subtract 3x from the left side of the equation, I better subtract 3x from the right side of the equation. That leaves me with 4y equals 8 minus 3x. Awesome, so now I have my y almost by itself. The only thing it's missing is that it has that 4 in front of it. And 4 is being multiplied to the y, so to undo the multiplication, I am going to divide both sides by the 4. So I get that y equals this lovely thing, and I am going to switch this side into two fractions rather than having one giant fraction. I'm also going to erase what I did down here because it's just going to get in my way. Okay, so now I've technically solved for y. I have it exactly in the form that I want. The y equals some expression that has x's in it. I'm going to write it, I'm just going to simplify the right side of the equation so it looks a little nicer for us. So we know that 8 divided by 4 is 2. And then what I'm actually going to do with this x is, instead of making 3x over 4, I'm going to make it 3/4 x, which is the same thing. So that is just this is usually a more preferred way to write it. You may also see it written very frequently as negative 3/4 x plus 2. Sometimes we'll switch the order so that the x's come before the constants. Honestly, the difference between these two is basically nothing, so I want you comfortable switching between those two forms, but I'm not really picky about which one it's in. They're both mathematically exactly the same. So let's take a look at another problem. Maybe it adds to just a different kind of trickiness to it. So let's say I have 2x plus y all divided by 3 is equal to 5. So this one looks a little more complicated than the other one did, but this one will actually, I think, be a little bit easier for us to solve. So we're trying to get y by itself, so we need to get rid of everything that's surrounding the y, which means that we need to get rid of that 3 and that 2x. So we are going to start by getting rid of the 3, and the reason we're going to do that is because this entire left side of the equation is divided by 3. So in order to get rid of, or to undo that division that's happening, we are going to multiply both sides of this equation. I'm actually going to switch colors just so that we can see what the original problem was. Times it by 3. So I'm going to multiply this side by 3 as well. I'm going to switch back to black now. So now these 3's cancel out, and my left side of the equation is just 2x plus y. 5 times 3 is 15. So 2x plus y equals 15. Now I just need to get rid of that 2x that's being added onto my y. To get rid of that addition, I am going to subtract 2x from both sides. And I will get that y equals 15 minus 2x. And again, you might see this written more commonly with the x first, negative 2x plus 15, but I really do not care about which one of these last two answers you have, as long as you can get there and you can see that these two are the same. So important features and all important components of solving for y is that you need to maintain the balance, like we talked about. Like in this one, we subtracted, let me get my highlighter out so I can do some pointing. We subtracted this 2x from both sides of the equation. That's a critical component of keeping both sides of your equation equal. It's also important to recognize what operation you need to do to get rid of terms. So for example, I wanted to move this 2x that was on the left side of the equation to the right side of the equation. Since it was being added on the left side, I had to subtract it. So the way I get rid of addition is by subtracting. In my first step, I wanted to get rid of this 3 that was being divided, and so I multiplied. So to get rid of division, I multiply. So recognizing what operations undo each other is another critical component of solving for y. And just remembering that the goal of solving for y is to isolate the variable, right? Get that y all by itself.